I'm Akibur Rahman, so I'm basically a system architect at Padis. I have studied information engineering from HW Hamburg, and since then I'm full-time at Padis, and I also did my internship and thesis and other, and also as a working student at Padis. So it's about like 4 years now. Yeah, that's basically about me. And going to, about Padis. Padis is actually a tech-enabled logistic company, and we basically provide SaaS for warehouses, so software as a solution for warehouses. Like the main product of our company is warehouse management system, and this basically helps with everything in the warehouses, and we also have some other products, and we'll talk about more in the next slides. So yeah, our products. One of the most important one is the admin panel, which is the warehouse management system. It's basically web application. And then the other one is MDE, which is basically mobile and data entry, or like handler. So this basically, MDE is basically a mobile application. It helps the people in the warehouse to keep a track of the inventory, and also help with the articles in the warehouse. And the next one is the fulfillment portal, which is also an web application. And this is basically for the clients of our customers to view their articles. And for Stack to build this application, we used various types. For example, for the web application, we use React.js and along with Next.js, and for backend we used Nest.js, and one or few with Spring. Similarly, for mobile application is for React Native, and fulfillment portal also uses React.js and Next.js. That's summary of our application stacks and everything. Yeah, to give you also a little bit overview of our infrastructure is also very important, so that you understand the next few slides. Also helps you to get to know some components from the diagrams. For infrastructure, we use AWS Cloud, Kubernetes, of course, for the backend system, and we also use Helm to deploy services into Kubernetes, and Jenkins for CI and CD, and of course GitLab for the repositories. We also use a microservice architecture, which actually gives us a lot of flexibility in terms of deploying services, and that's basically it about the infrastructure. I will quickly show you about the system architecture. First of all, the old one that we had about 1 year ago, and the issues that we had with this system, and also show you the pros and cons and the next slides. So basically, this is this was the system that we had in like 1.5 years ago. To basically illustrate what is the whole system is, we start with the ingress controller, which is basically the main control of the Kubernetes, and one of the most important or like major component of our system was the authentication and user management service, which was written in Spring. This takes care of login, registration, user management, and also generates a token for the user after a successful login. And it used asymmetric keys, private and public. So basically, private keys to generate the token, and their own public key to validate the token, for example. Of course, it used OAuth2 and JWT tokens. And also, this was a completely written from the scratch, and it was fully customized based on our need. And it also had the user management stuff inside, and also the login and registration stuff. But everything was and those were done by the API call to the service. And we also use Gateway, which is basically a Zool router from Netflix. This is a really great service, and this also acts as a service discovery into the Kubernetes itself, automatically discovers all the services that are available in the namespaces. And then we can also create routes into it, and to access the services internally. And of course, they're also written in Spring. And then we also wanted to implement access control policy service, which was the most important one for WMS software. And we ended up writing from the scratch as well. Also, it didn't really go well, so as you can see, it's crossed out. So we didn't use it at some point because it was really messy, and it created a lot of complicated structure because we have microservice architecture, and obviously to bind roles and policies for the users and users, it becomes really complicated in microservices. So this was, since this was an independent service, and it was really not helpful to write our own ACP service from the scratch. So we did not, at some point, we did not use it anymore. And then from then we were started to look, looking into a solution that provides out of the box this access policy stuff. And to also talk about the front-end app and the other backend services, they are basically also deployed into Kubernetes, and some of them are written in Nest.js, and most of them are written in Nest.js, and some of them are written in Spring. That's the overall architecture of our old system. And this was working perfectly fine from until the last 1.5 years. There was no problem, and we never had any issues. The most major problem for us was to make changes, for example, to make changes into the authentication service. And also we did not have any access control policy service at the time, and we were basically relying on groups or roles like admin or user, for example. And yeah, that was already too complicated. It was too complicated for us to handle or give permissions for certain stuff. And yeah, and then we started to think about new solutions. But also I also want to tell you about one or two use cases to give you more understanding about why it was too bad, this system. So for example, this two use case will definitely help to understand the old backend system a little bit. So the first use case, for example, the user wants to log in. So we start the flow that user provides these credentials into the endpoints, and then a request for the token. Then the service validates. In this case, the service is the authentication service and user management, and then it validates whether this user exists or not. And if the user exists, then it creates a JWT token using the private key that the authentication system has, and gives the access token and also the refresh token later on to refresh the access token. And with this access token later on is used to get the resources. So the user provides this access token to fetch the resources, And then and all the services basically have their own public keys. So the service itself can validate if the token came from the right place, the right authentication service. So with public key, it was it is validated, and then the information from the token was extracted to further process. And then if not, then the user gets unauthorized. And that was basically the overflow of our whole system. So as you can see from the diagram, all the services, all the backend services, the microservices, they had their own public key to check if the token is a valid one. So to talk about the pros and cons, obviously, like I said, the system was completely customized based on our need, and the access token generated using asymmetric keys, which is obviously good, because this gives us the possibility to rotate the keys at any time we want to, because we also keep the keys in the server, so that every time a service or any service is deployed, it uses the key that is from the server. So it was easy to change them, and obviously the fake access token was never possible. And this makes sense because the private key that the authentication service has, if no one has the private key, no one can create this access token. And yeah, this was the basic pros for our system. The cons obviously make sense that these services are not independent at all, because all the services in the system requires to validate each and every request that comes into them, and then extract the information out of it. And this was, I would say, this was too much, because every service needs to do it for every request, and this in terms of time, in terms of time, and also response time, and this also is decreased, obviously. And another most important point in terms of security, API flows for browser-based applications are bad practice. Obviously, this leads to several CSRF attacks and other problems, and the grant type that we used at the time was actually basically deprecated at the moment. Yeah, and then we started to think about our system step by step to understand what we can bring into our system, what can be replaced, and which type of services can provide or can come easily into our system without breaking anything. So that was the most concern, because our backend system was working perfectly fine, and it was already used in the production. So we didn't want to keep any gap, or completely destroy our backend and create a new one. So we wanted to migrate slowly, so that the applications are still running. And this was the most important task for us. And also, to do that, I started reading into Ory stack, and it was really easy to follow at the beginning. With the configuration stuff, it was not that easy, but with times it got easy with the community and everything. And then we started to use Ory stack into our system, and this is basically the current architecture right now. To give you more overview about how it is right now, and I will just go through quickly with the components of the systems. So we just replaced, as you can see, we replaced the authentication service with the Kratos, and then we also use Hydra for generating access tokens. But access tokens are basically used by our ETL services like Airflow. And then we also brought some other small services. For example, one of the most important services, the middleware. So this is basically an integration service of every components of Ory. The reason behind this, I will just tell you in a bit. And then we also wanted to keep Outkeeper because this is a policy decision point, and it consists of access rules. And this is really nice service, and because every request that comes in, we can actually say this request should be routed to, or actually this request should be authorized, or this request should be muted, or should have an extra header, for example. So this was really an important one for our system. And we still kept gateway service because this is the one point where our all services, backend services, are registered, and this is, and we also have some business logic implemented into it. So this lets us keep the system same as before. And we just say for every route that it comes into Outkeeper should go to gateway service, and later on reach the end service. To talk about middleware, the reason behind it is since we have multiple applications, and then for example we say, okay, we want to have separate user database and separate Kratos, and this was only possible when we had a middleware service which takes care of n number of Kratos and n number of Keto, and also n number of Hydra. And similarly, then we have n number of login for different applications. So, and this system is really stable because most of the services are independent, and making changes to one of to any of the service does not break anything. And also, I will show you a little bit about how I implemented, or also show you the configurations of the current infrastructure, so that you have an idea how it can be implemented, for example. And I also want to talk about one of the important things, which is the middleware and also the Kratos. So for the Kratos, it really helps us because the session tokens and the login and registrations are all browser-based. So it takes care of the security stuff, which is really important for us. And for the login services, basically we took the SSO from Ory, where we are using as a login service separately. And Keto, we are still in development, so we are still building with Keto to use the SCPs, access control policies, and this is still in development. Hydra, like I said, we use the Hydra in combination with Kratos to get the identities from Kratos. And these tokens are basically used in the Airflow jobs to take care of some ETL processes. That's basically the new infrastructure and the new system architecture, and this is working really great into our system. And we so far never had any problems. And of course, at the beginning, we had a lot of troubles implementing this into our system, which makes sense because such complex architecture are not easy to bring, and especially when replacing components of an existing system is always difficult. So with times it was easy. Then I will quickly show you about the implementation, or so-called demo, to talk about these the structure that I just showed in the previous slide, to give you an understanding how it is implemented into a system. Kratos. So let's start with Kratos. From the diagram, from the system diagram, if you remember, we talked about n times of Kratos into a system for different applications. So this is already possible. This is the Helm chart of Kratos, the easy part is that you just need to have the identity defined, which is really, and you can use different identities for different application, and then basically say that for this application we have for app A, this is the login page you have. Then obviously you need this login page deployed, and then this should really work. And also show you, and similarly for B, and then we can just implement it using Helm chart, which is also straightforward. In this case, if you want to use a different version of Kratos, is also with this command line, and then provide the values and should be deployed into Kubernetes. And then going to Outkeeper, which is the most important one, and this is the most interesting one. And for example, I showed in the diagram that the middleware service talks with the Outkeeper in this case, and then we can say, okay, we have trusted issuers, not only A and B but multiple, and then Outkeeper actually takes care internally if the token is coming from this source. And then this is to introspect this particular token, we send request to our own service, and then the service itself can handle everything. And yeah, similarly for cookie session, we send to middleware service, and we only take the cookies that are coming from Ory Cloud session. And then this for the web application, and similarly for our mobile application, we use this strategy that we write, we take the API session token from one of the custom header, and then give it to middleware service to verify it. Authorizers, which is for the Keto stuff, we also use the similar approach. Send remote backend call to our middleware service, and provide the load. And this is the most interesting part. At the time we were implementing our Ory stack into our system, when Keto was I think it was 0.5, which had the old system, and this was working perfectly fine for us. And the current version with Zanzibar, we actually haven't. It's not really useful for us at the moment. So this is, since this was the working version, so we're still using the old one. And yeah, basically take all the information from the session and provide it to the service to take care of the rest of the stuff. Yeah, mutators for this is important for our service backend services. And so after the request reaches to our backend service, it basically gets an header, which is basically user, and this is extracted from whatever the if it's a token or if it's a session from Ory Kratos, then it's extracted, and then the service can easily use it to provide resources. Yeah, and quickly show you also the access rule for different application if you want to have into system. So we can just say, okay, we have an app A, and then app B is, then you just say here that the authenticators are different, and you want to handle with different authorizer, different authorizers and different authenticators, and so on. Then it's basically easy to write in. Yeah, and also wanted to show you the most other important part for backends. Yeah, so for backends, we can just say, okay, we have a request that are coming in, should go to our gateway service, and then we also want to say our authenticators are this one, if there is a token available, and or say, okay, if there is a cookie session available, or say, okay, if there is a barrier token available. So meaning to say, this could be the ETL service requesting from Airflow using Hydra token, and this could be the a person logged into our admin panel using from the browser, and this could be the MDE, this requesting from the mobile application.